So, hello there. Upon encountering the theme of this year's TEDx event, Shifting Perspectives, a multitude of ideas flew through my mind. I knew I wanted to delve into something science-related because that's where my primary interest lies. Reflecting on some of the major scientific breakthroughs over the past few centuries, I noticed a key similarity amongst them. Initially, a problem or paradox emerges that contradicts or undermines current scientific theory. Subsequently, the resolution of this problem paves the way for scientific development. Now the question becomes, how are these problems solved? Well, what I have found is that they're all solved in a somewhat similar way. This is a point that I'll get back to later on. But for now, if you've read the title of my talk today, your mind may have instantly gone to Einstein's theory of special relativity. At least that's where my mind went as soon as I heard the theme Shifting Perspectives. You may have heard about some of the weird and wonderful consequences of this theory, most notably time dilation and length contraction. However, it can be argued that these two phenomena are the consequence of a third and less well-known ramification of special relativity, simultaneity. This aspect of special relativity concerns when two events occur relative to one another. It is usually explained through the following thought experiment. Imagine a UFO moving relative to me at a high velocity. Now imagine an alien from inside the UFO emitting two beams of light in the opposite direction from the center of the UFO. From the perspective of the UFO, from the frame of the UFO, it is a UFO that is stationary, and it is the rest of the universe which is moving at a high constant velocity. As each light beam takes the same amount of time to reach either end of the UFO, it follows that each light beam takes the same amount of time to reach both ends of the UFO. From the alien's perspective, the two events of the light beam hitting the back and front of the UFO are simultaneous. However, from my perspective, as an external observer, I observe something very different. From my frame of reference, it is the UFO that is moving at a high constant velocity. The back of the UFO is moving towards the point of light emission, and the front of the UFO is moving away from the point of light emission. Einstein's second postulate says that the speed of light is constant in all frames of reference, and from this, it follows that I observe the light beam hitting the back of the UFO before the front. You can clearly see that the distance that the left light beam has to travel is much less than that of the right light beam, and because the speed of light is constant, it follows that it takes less time. So I disagree with Alien. I believe that the two events of the light beam hitting the front and back of the UFO are not simultaneous. Generally speaking, the back of the UFO lags ahead of time, and the front of the UFO lags behind in time. By time here, I'm referring to the proper time, which is the time measured by the alien from the rest frame. What this time lag means is that from my frame of reference, the back of the UFO is slightly ahead in space compared to what the alien sees, and the front of the UFO is slightly behind in space compared to what the alien sees. This is length contraction. I now want to use this intuition we have of length contraction to explain one of the fundamental forces of nature, the electromagnetic force, and all other contact forces for that matter. For the reason you or I can't fall through the ground or cannot walk through walls is the electrostatic repulsion of individual atoms on the microscopic scale. Now hear me out. Imagine our UFO somehow had a net positive charge, and it moves relative to a current carrying wire, which you can just think of as a flow of electrons. What do we see? Well, we see that the UFO slightly deflects away from the wire. There's this mysterious force. There seems to be no way to explain this force from our frame of reference as an external observer, because the electrostatic repulsion between the protons in the wire and protons in the UFO is perfectly cancelled out by the electrostatic attraction between the electrons in the wire and protons in the UFO. So in order to explain this mysterious deflective force, we must jump into the frame of the alien. From the alien's frame, the UFO is stationary, and it is the whole wire which is moving leftward. The protons, which weren't in motion previously, are now in motion, and therefore their length is contracted. The electrons, on the other hand, are now moving slower than they were previously, as their rightward motion is partially cancelled by the leftward motion of the whole wire, so their length is contracted, and we see something like this. You can clearly see that the protons are now much more densely packed, and the net force acting on the UFO is a repulsive deflective force, which explains the force I described earlier. We call this a magnetic force, and it explains why a current carrying wire produces a magnetic field, and why a charged particle moving past the current carrying wire experiences a force. However, I've just shown that the magnetic force is really just the electric force taken from a different frame of reference. They're really one of the same, part of a more fundamental force of nature, the electromagnetic force. In physics, we call such a parallel between two concepts a duality. One you may have heard of is wave-particle duality, and it was this finding that led to the quantum revolution in the 20th century. Anyways, so far I've only considered inertial, non-accelerating frames of reference. But what happens if we do consider non-inertial, accelerating frames of reference? Does Einstein's first postulate that the laws of physics are the same in all frames of reference still hold? Well, the simplest case would be a constant force causing acceleration. Imagine how a UFO described previously now accelerates towards the Earth. There's obviously some form of thrust force causing this acceleration. However, from the non-inertial or accelerating frame of the alien, it is the UFO that is stationary, and it is the rest of the universe which is accelerating. By symmetry, this acceleration is equal to in magnitude, but opposite in direction to the acceleration that an external observer perceives the UFO to have. However, only a force can cause an acceleration, and therefore from the non-inertial frame of the alien, we must conclude that a force simultaneously and instantaneously acts on the whole universe. This seems absurd, especially if we take Einstein's second postulate that there is a constant universal speed limit into account. That's why we call such a force a fictitious force. The force is not real insofar as there is no real interaction of particles which causes the force, but it's a force that we must introduce into a non-inertial frame of reference for the laws of physics to still hold. This example of fictitious forces that I just gave is not that interesting, and actually my favorite examples of fictitious forces arise when we consider a rotating frame of reference. So now imagine that you're far out in space in the absence of any gravitational field, in a ring, spinning with the ring, a centrifuge. So we observe two interesting phenomena from our frame of reference if we throw a ball upwards now. The first thing we see is that the ball follows the trajectory of a projectile. However, there's no gravitational fields. So how do we explain this force which makes the ball constantly accelerate until it hits the ground? We must introduce another fictitious force, the centrifugal force. Just something else to note is that the ball slightly deflects ahead of us as well, and this is the product of another fictitious force, what you may have heard of, the Coriolis force. So when I throw the ball upwards, it maintains its initial horizontal velocity due to inertia. However, it enters a region of the centrifuge with a lower velocity, and therefore it moves ahead of the centrifuge at this point. Now, to show that these forces really are just fictitious, they're not real, if we jump into the reference frame of an inertial observer, i.e. one stationary looking at the centrifuge spin from outside, we see this. We see that the ball does indeed travel in a straight line at constant velocity. No fictitious force is needed. And if you look at the man as the ball moves, you can clearly see why the man would perceive it to follow the trajectory of a projectile. I think this goes to show that fictitious forces only need to be introduced into non-inertial frames of reference in order for the laws of physics to still be held. Anyway, I digress. Fictitious forces are definitely fun to think about, but we can also use them to gain a deeper understanding of the world around us. You see, Newton's model of gravity involves a gravitational field, which you can think of as an ever-evolving imaginary fluid that fills up all of space, assigning a value to each point in space. These values correspond to the distribution in the matter within the field and determine the magnitude of a force exerted on a mass placed at that point within the field. You may have spotted a couple issues with this model. Well, for one, it suggests that the force of gravity can act instantaneously between any two objects. This seems absurd, especially if we consider Einstein's second postulate that there's a constant universal speed limit. Secondly, you may have been able to draw parallels between this model of gravity and the model of fictitious forces that I drew upon earlier. Would it make sense to say that the Earth, for example, exerts a force simultaneously on the whole universe? Or would it make more sense to say that the force is actually exerted on the surface of the Earth? And it is this force that gives the illusion of gravity, just as the thrust force acting on the UFO gives us the illusion of a fictitious force acting on the rest of the universe. Essentially, what I'm saying here is if I jump up, I don't accelerate towards the ground. It's the ground that accelerates towards me. But if we accept this, we must accept that the Earth, and all other celestial bodies for that matter, are constantly growing, getting bigger, as their surfaces constantly expand out in all directions to all objects that they seemingly exert a force on. Again, this is clearly not happening, it's clearly false. So the only way we can reconcile this is by somehow saying that space itself is shrinking around a massive body. Space-time is warped. This is the premise of Einstein's general theory of relativity, the best theory of gravity to date. Essentially, we have the illusion that a massive body causes an object to accelerate, when in reality, the object doesn't accelerate. It follows its natural path, what's known as the geodesic. But it's the curvature of space-time which gives us the illusion of gravity. So in a way, you can think of gravity like a fictitious force. It's not exactly a fictitious force, but it's a very useful analogy. And by thinking about fictitious forces, we can get very useful insights into stuff like this. Anyways, back to the question at hand. What is the common thread amongst all the scientific advancements that I've discussed today? Well, to put it simply, we've reasoned through each of the concepts discussed today by changing our reference frame. By shifting our frame of reference, we've been able to get an intuition on the electromagnetic force and the so-called fictitious forces, in turn allowing us to challenge Newton's model of gravity and gain an intuition of both special and general relativity. By changing our frame of reference, we are able to see things in ways which we couldn't have before. And it's this that is a catalyst for scientific advancement. My goal here today was not to provide you with a mathematical framework of physics, but rather an intuitive understanding of the world around us. As a school student, I'm yet to delve into the complex intricacies of our physical theories. However, it's being able to conceptualize them in such simple and captivating ways that makes me passionate for physics and excited for what's to come. Thank you for listening.